Welcome, Mindsetters, grade 12s. It is your time to shine with Looney and Liesel. How are you,
Hello
Liesel?
there, guys. I'm very well, thanks, and you?
I'm good, thank you. So what are we doing for the grade 12s today?
Well, we're having a look today at data handling. So that's really a topic that the grade 12s did in grade 11 already, but there's no revision usually in grade 12, so we're giving the guys a chance to go over, and very useful for the grade 11s to watch as well. If they've done it already, again, nice revision. If they haven't, then they'll have a heads up on what's to come.
Okay, cool. I'll send you quickly to your board. Grade 12s, you heard it. Data handling, it's all about the data handling. Yes. Guys, I do know what I'm talking about, but it's just, yeah. Remember, grade 11s, you can also watch, but now it's time for the grade 12s. Remember, you guys can keep in touch with us on Facebook. Our page is facebook.com/learnextra. On Twitter, our handle is @learnextra. Remember, you can download the show notes, the videos, the schedules. If you want to see other products that we also offer, you can go on to learnextra.co.za/live. So with all that said, thank you so much for tuning in. Liesel, I'll take it straight back to you.
Right, guys, welcome to tonight's show on data handling. So let's have a quick look at what's in store for us today. We're going to start off by having a look at our measures of central tendency. Now, our measures of central tendency are our 3 M's. That is the mean, the median, and the mode. Now, grade 11 isn't even the first time that you learned about mean, median, and mode. You should have done these in the junior years already, so this shouldn't be too much of a stretch. So let's have a look quickly, firstly, at the mean. Now, another word that we can use for a mean is the average. So when we're calculating the mean, what we're basically doing is we are adding all of our values together. That's why we use the sigma sign. And we are dividing by how many pieces of data we have. And remember, the X with a bar on top is the sign that we typically use for the mean. Right, so that's the mean, the average. The next one that we're going to have a look at is the median. Now, the median is the value that is exactly in the middle. So if you take your data and you arrange it from smallest to biggest or biggest to smallest, the middlemost value is the median, and we also use the sign Q2 to indicate the median. So the median divides our data into 2 equal parts. Right, then next up is the mode. Now, the mode is the value that occurs most frequently. Now, mode, in Afrikaans, we use the word, instead of fashion, we say mode. Now, you can think of the mode as the fashion. What is the fashion? The fashion is what everybody's doing. So the mode is the data value that occurs most often or most frequently, and we don't really have a special sign to indicate the mode. Right. So we know now what the mean, the median, and the mode stand for. We're also going to have a look today at something called the 5-number summary. Now, the 5-number summary are those 5 important data values that you need in order to draw a box and whisker diagram or a box and whisker plot. So let's move on to the next page. We've spoken about the mean, the median, and the mode. Now we're going to go on to the 5-number summary. So for the 5-number summary, you need to have the minimum data value. You also need the maximum data value. The next value that you need is quartile 2, also known as the median. Remember, the median is the middlemost value if you've divided your data into 2 equal pieces. Then we also need quartile 1 and quartile 3. Now, we'll speak about Q1 and Q3 a little bit later, but basically Q1 is if I take the lower half of the data and I divide it in half again, that gives me Q1, and Q3 is if I take the upper half of the data and I divide it in half again, that gives me Q3. Right, so let's have a look at a practical example. So we're given a very straightforward list of data. We're not told what it is. It just says, consider the following list of data. It could be that we asked students how many times per year they went to see a movie at the movie theaters, and the data was collected. The data was collected from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people in total. Right. So what I'm going to do now is from this data, I'm going to write down my 5-number summary. Now, if the data is not arranged from smallest to biggest, boys and girls, you have to arrange it from smallest to biggest. Most of the time, we save you guys that trouble and we do it for you like I have here. Right, so let's get on with the 5-number summary. First up is the minimum value, and the minimum value is quite clearly 2. Next up is the maximum value. So we go to the upper end of the data, and the maximum value is 9. Now, I'm going to carry on and determine Q2. Now, this is very important. I've got an even set of data values. I've got 10 pieces of data. So, if I've got an even piece of data values, what will happen is my quartile 2 will fall between two pieces of data. Have a look. I've divided the data in half. I've got 1, 2, 3, 4, 5 pieces of data to the left, and 1, 2, 3, 4, 5 pieces of data to the right. Now, Q2 falls between 5 and 6. So what I do is I add 5 and 6 together, and I divide them by 2, and therefore my Q2 will be 5, 5. Just bear in mind, boys and girls, if there was, let's say, 9 pieces of data, then your Q2 will fall onto the 5th data piece. So then it's not between 2 pieces of data, so just bear that in mind. Right, so what I've done now is I've divided my data into 2 halves. This is my lower 50%, and over here, I've got my upper 50%. Now, to get the value for Q1, I need to take my lower 50% and divide it in half again. And have a look here. Exactly in the middle of this half is the number 3. So quartile 1 has got the value of 3. And again, exactly halfway in the top half, there's quartile 3. And quartile 3 has got a value of 6. So very, very quick and easy. If you know what you're doing, easy to get the 5-number summary. Right. So once you have the 5-number summary, more often than not, we will ask you guys to draw a box and whisker plot. Box and whisker plot is very, very straightforward to draw. There's just a couple of rules that you have to bear in mind. The first one is, it really is preferable that you use a ruler. So what I'm going to do is I'm going to use a straight line, and I'm going to put it over there. Then on your straight line, you now need to indicate the number line from the minimum up to the maximum. So the minimum is 2 and the maximum is 9. So I'm going to count in ones. Obviously, if you've got widely spread out data like 10 and 500, you're not going to sit and count all the way to 500. That'll be silly. So let's do that. 1, 2, 3, 4, 5, 6, 7. Right, so you've got your number line going on here, and my number line starts. You also don't have to label every single one. I'm going to do it just for now. That's 2, 3, 4, 5, 6, 7, 8, and 9. Then what you do is, above your number line, you draw a line onto your, I'm going to use a different color, let's just make that look a little bit better. So I'm going to draw a line above my minimum value. Then I'm also going to draw a line above my maximum value. Then I go on to quartile 1, and there's going to be a line over there. Another line above quartile 2, that's at 5.5, so that's about there. And then finally at quartile 3, which is at 6. Then what we do, boys and girls, and I'm going to stop trying to use the straight line here because it's just not working. My middle 3 lines get joined together to make my box, and then from my box I extend to the minimum value and I extend to the maximum value to draw my whiskers. So that is how I draw a box and whisker diagram. Right. Let's carry on. Just a couple of things that we need to know again about the mean, median, and mode, our measures of central tendency. The mean and the median help us to decide whether our data is symmetrical, skewed to the left, or skewed to the right. Now, if you calculate the value for the mean, now remember that the mean would be your average, and you subtract from the mean the value from of the median. If your answer is 0 or close to 0, we can say that our data is symmetrical. Then, if our mean minus the median gives us a positive answer, we say that the data is skewed to the right or positively skewed. This is very, very important, boys and girls. You've got to know this. And then finally, if we take our mean and we subtract the median and our answer is negative, we say that the data is skewed to the left or negatively skewed. Right. Now, if I have a look at this data set, I did calculate the mean a little bit earlier on, and I think I found that the mean was 3,4, if I'm not mistaken. Now, our median, we said, was 5,5. And it's clear that if I subtract the median from the mean, I get a negative answer. So that means that in this case, my data is skewed to the left or negatively skewed. Just to show another little depiction, here I've got negatively skewed data. So what will happen with your negatively skewed data? Your value of your median, your middlemost number, will be bigger than the mean, and that will be the profile of your normal distribution. Very important, the median is bigger than the mean. Then if we have a look at our symmetrical data set, the mean, the median, and the mode, all 3 measures of central tendency, are virtually on the same place. So if I subtract the mean and the median from each other, or the median from the mean, I get an answer of 0, and I will see that my data is in a nice, evenly distributed bell curve like that one. And then finally, if my data is positively skewed, my mean will have a bigger value than my median, and my data, my normal distribution, will look a little bit more like this. Boys and girls, it's important that you know these definitions, so take a little bit of time to commit them to memory. It doesn't take too long. Most of data handling doesn't involve too much learning, so this is well worth your while. So we're about to go on to our first practice question, which involves the mean, median, and mode, as well as the 5-number summary and a box and whisker plot. But I think at this point, I'm going to go over to Lunia and just see how our learners doing out there. Are they understanding what we're talking about?
Okay, firstly, we've got a lot of questions, but I'll just give you 3 for now. Mosa is asking, hey Liesel, can you please show me how to indicate lower quartile, median, and upper quartile from the graph?
We're going to get to that a little bit later when we do ogive. So that's definitely happening.
And then another
Stay
question
tuned.
from Troy Walden. Does it matter if maximum in minimum on dots? Oh, if maximum and minimum on dots in box and whisker plot.
Okay, so I think what this person is referring to, and that is perfectly acceptable. Let's just do it over here. If you do your box and whisker plot, if you do a dot to indicate your minimum value and a dot to indicate your maximum value, that's also perfectly acceptable. That's fine. It's just a different way of representing the data. All right, next one.
Last question. Looney, can you ask Liesel on how to find the Q1, Q2, and Q3 from an ogive?
From an ogive. Now, guys, the ogives or the cumulative frequency graphs, I know from my students too, we battle to find Q1, Q2, and Q3 on them. We're getting there. So stick with us. We'll make you famous. It's our next question.
Last one. Just this one person. Rancy Tolo, please send my love to Liesel Looney. I just love her lessons. That was just
what a fantastic compliment. It's so nice to teach and know that we're being appreciated. Right, so guys, don't stress about the ogives. We're getting there. Okay, so boys and girls, sometimes if we want to mix things up a little, we won't just give you the data set and say, find minimum, find the maximum, find Q1, Q2, and Q3. We might give it to you in a little bit more of a coded way. That's fine as long as you understand what you're doing. It shouldn't be a problem. Now, very important is that you guys realize that Q1, Q2, and Q3 divide the data into quartiles. That's what Q stands for. So it divides 25%, 25%, 25%, 25%, and that'll help you with this question. Right, so the question says the following information is given on a particular set of data. The values go from 40 to 95. So from 40 must mean that the minimum value is in fact 40. Up to 95 must mean that the maximum value is 95. So I've already got two values from our 5-number summary. They give us the median. They say the median is 79. So Q2, it is given to us that Q2 is 79. And then it says 25% of the values are less than or equal to 62. Now, boys and girls, what does Q1 do? It divides, it gives us a boundary for the first 25%. So really, what this is it's telling us that Q1, my first quartile, is 62. So if you want to remember it like this, Q1, up to Q1, I've got 25% of the data. From Q1 to Q2 is another 25%, but that brings me up to 50% of my data. And then from Q2 to Q3 is another 25, which brings me up to 75%. So by saying that 20% of the values are less than or equal to 62, we are being told that Q1 is 62, and then 75% of the data is less than or equal to 90, so that means that Q3 is 90. So see, boys and girls, if we use our heads, it's very easy to get the 5-number summary. I read through this, I had it immediately. So the first question is to draw a box and whisker diagram of this data. So boys and girls, I've gone through that now in quite a lot of detail. You'll do on your number line from 40 to 95. On 40 and 95, you'll put either a line or a dot. As we said, that's also fine. And then you will put another line on Q1, which is 62, on Q2, which is 79, and on Q3, which is 90. And those guys you will connect. Now, you have to use a proper scale if you do this. And I was about to take a shortcut, but I think I'm not going to. Let's draw this quickly. I'm going to do it roughly, but I'll use a proper scale still. So what I'm going to do is I'll say, right, my lowest value is 40. So let's go 40, 50, 60, 70, 80, 90, and I'll take it up to 100. So my maximum value is over there at 95, it gets a line. My minimum value is over here at 40, that gets a line as well. Then my Q1 is 62, that's just a little bit above 60 there. My Q2 is 79, that's just below 80. And then over there, now boys and girls, please use a ruler. And there is my box and whisker plot, quickly. Right, let's look at the next question. Write down the range. Now, boys and girls, the range is always the highest minus the lowest. So the highest value in this set of data is 95. The lowest is 40, so 95 minus 40 gives me a range of 55. Easy. And then the next question asks me about the interquartile range, abbreviated as IQR. Very important that we remember that interquartile range is the difference between the third and the first quartile. So our third quartile was 79, and our first quartile was it 62? So you'll say 79 minus 62, and that gives you 79 minus 62. I'm having a bit of a blonde moment here. What is that? Let's do it the old-fashioned way. 17. There we go. So my interquartile range is 17. And then quickly, the last question asks me, state whether the data is skewed or not, and if it is skewed, is it skewed to the left or to the right? Now, we know that the definition for skewing is to have a look at the difference between the median and the mean, but if you do look at your box and whisker plot, what you do is, if you're unable to calculate the mean, because I am unable to calculate it, I don't have the individual data pieces, I will look at this whisker. There is a longer whisker to the left than there is to the right, so I will say that my data is skewed to the left. Now, boys and girls, we're going to have to go to an ad break now, but please don't go away, because next up I'm going to show you how to draw a cumulative frequency graph or an ogive, and I'm also going to show you how to read Q1, Q2, and Q3 off of that ogive. Over to you.
All right, mindsetters, Lisa said it all, so don't go anywhere. We'll be right back straight after this. Welcome back, mindsetters. I hope you guys got yourself some water and some juice and you're ready to start again. We have some few questions here for Liesel, so I'll get straight to them. Vusi Kevin is asking Liesel, if I may ask, what is the difference between the variance and the standard deviation? And how do you get the standard deviation by use of a calculator? And how do you get the standard deviation if you don't use the calculator?
All right. Now, the difference between variance and standard deviation is quite simply that the standard deviation is the square root of the variance. So let's say your variance works out to be 16, then your standard deviation will be the square root of 16, which is 4. All right. Now, mostly in real life, we don't really use the variance so much. We use the standard deviation. And your calculator also directly calculates the standard deviation for you. So if you've got the standard deviation and you want the variance, what you need to do is take whatever the answer for your standard deviation is and square it. Now, Vusi, we're going to get to variance and standard deviation in the final part of the lesson. I am going to run you through very quickly how to calculate the standard deviation manually and how to use your calculator. Now, most of the time, you will be allowed to just use the stats function on your calculator. And the good news is, if they do want you to calculate it manually, they'll give you a table to fill in, which will make your life quite a bit easier. So we are going to get to that, but in short, to answer the first part of your question, take the standard deviation, square it to get to the variance, and if you want to get from variance to standard deviation, then you square root. Now, we had a lot of questions before on the ogive, so now I'm answering the questions from the first session, and we'll get to your question just now. So guys, we're going to have a look now at ogives also, or ogives. There's so many different pronunciations, who knows? They are also called cumulative frequency graphs or cumulative frequency plots, which is probably easier to pronounce. Now, a couple of things that are important with an ogive is firstly, the points that we need to plot. Now, the best way to show you guys this is by just doing an example, which we will do now. But the points that we plot is always the end of the class interval, that is our x value, plotted against the cumulative frequency, which is our y value, right? Cumulative frequency, boys and girls, not frequency. An ogive is usually quite a smooth curve. If yours looks a bit like this, it's probably because you plotted the frequency as your y value and not the cumulative frequency. Another thing that people often lose marks for on the ogive is that they forget to label their axes. That's really, really important. Okay, so let's get straight into it. So the question says 50 motorists were asked to record the number of kilometers traveled in 1 week, and the following table shows their results. So they say that 2 motorists recorded that they traveled between 10 and 20 kilometers, and that then means that the cumulative frequency is 2. Now, basically what they're going to ask us in the first bit is to complete the table by writing down the missing values. Now, if in the class interval 20 to 30, my cumulative frequency is 9, that means that up to 30 kilometers from the beginning, I've now spoken to 9 people. So if 2 people fell in the first class, then it must mean that the number of motorists falling from 20 to 30 must be 7, and the reason for that is because 2 plus 7 gives me 9. Now I say to myself, right, after the next class interval, which is 30 to 40 kilometers, I now have 13 people in my cumulative frequency. So that must mean that this value over here must be 4, because 2, 9, and 4 give me 13. Hopefully you guys can start seeing the pattern emerge. Then I jump from 13 on my cumulative frequency to 26, so that must mean that the frequency, this is just the frequency must have been 26, and then I go from 26 all the way up to 42, so that must mean that this was 16. And remember now, 50 for my final cumulative frequency, so that must mean that the last frequency is 8. Now guys, you have to be able to do this 2 ways. Sometimes we give you guys the frequency and we ask you for the cumulative frequency, and other times we ask you the other way around, as long as you realize that the frequencies up to this point have to add up to the cumulative frequency. So 2 plus 7 is 9, 2 plus 7 plus 4 is 13, and so on. You won't have too much of a problem. Now, if you are asked to sketch an ogive, I spoke to you guys a little bit earlier about the important points to plot. Your x value will always be the end of your class interval. So my first coordinate is going to be an x value of 20 and a y value of 2. So the x value is the end of the class interval, the y value is the cumulative frequency. So let's carry on with that. And what I like to do is I like to make a little coordinate set for myself to plot here. So I say, right, the end of the first class interval is 20. The cumulative frequency is 2. So the first point that I will be plotting will be 20 and 2. My next point will be the end of the class interval for the next interval, that's 30. And the cumulative frequency, which is 9. Then it goes 40 and 13. 50 goes with 26. I'm sure you guys are getting the idea. 60 goes with 42. And finally, 70 goes with 50. Now, it's very important, once you've done your points to plot, to also go back 1 point. So this is going to be important when you sketch your graph. So I'm saying to myself, if my first class interval was 10 to 20, if there was one before 10 to 20, what would that have been? It would have been 0 to 10. And then you take that x value that you've now thought out, and you plot that with 0. All right. So once you've got your points to plot, think to yourself, and this is only if it doesn't start from 0, of course. So if it doesn't start from 0, my previous one would have been 0 to 10. So 10 is my x value, and my y value is 0. Right. So now the question says to draw the cumulative frequency curve, and we're going to do so by plotting these points. I've already got the axes, so 10 and 2 and 20 and 10 and 0 and 20 and 2. All right, so 10 and 0 I will put over there. 20 and 2 slightly up. My next value is 30 and 9. So let's go back to my graph. 30 goes with 9. Looks a little bit more like 10, but you guys will excuse me. 40 goes with 13. X value of 40, y value of 13. 50 and 26. 50 and 26 over there. 60 and 42. 60 and 42. And then finally it was 70 and 50. So 70 goes with 50. And then what we will do is connect our dots with a nice smooth curve, boys and girls. Nothing like that. It has to be smooth like you would draw a parabola. Important. On my y-axis, cumulative frequency, and on my x-axis, number of kilometers. So a couple of things that are important so far. End of class interval, cumulative frequency, those are our points to plot. Remember, if your values don't start at 0, go 1 back. That's that one. Connect in a smooth curve, and remember to label your axes, cumulative frequency, and number of kilometers. Now, we get to the point, we now get to what a lot of you guys were asking me about. You were asking me, how do I get from the OGAV, or the cumulative frequency graph, how do I get Q1, Q2, and Q3? Very important is that when you are reading off your quartiles on an OGAV, you will always start at your y-axis or your cumulative frequency axis. Now, in this case, if we have a look at our table that we did before, a total of 50 people were asked about their driving habits. So I'm going to start off by looking for Q2. That's my median or my middle value. And I simply say to myself, what is half of 50? Half of 50 is 25, and I then take my pen or pencil, and on 25, I'm now going to read off over here. So let's just see, that's 20, 30, 40. So 25 is about here. You draw a line until it hits your ogive, and then you take that line down. And whatever that value is that you're reading off, and obviously we have to leave a little bit of a margin for error, but this looks like it's between 40 and 50 definitely, and it looks like it's perhaps a little bit closer to 50. So over there is my Q2, and I'm going to guess it to be around 47. So all I did is I said there were 50 motorists in total. 50 motorists divided by 2 is 25. I found 25 On my y-axis, I drew a line until I met my ogive, then I went straight down, and I read it off over here. So the median number of kilometers driven is about 47. It'll definitely fall in the class interval 40 to 50. Right, so that will be my median interval if I'm looking at the intervals. Okay, then if you want to read off Q1 and Q3, you will again have to halve. So this scale is not exactly ideal, but we'll now say half of 25 is 12,5. So now I'm going to do my best. That's 0, 10, so let's say 12,5 is about there. I'm going to draw a line to my ogive, take it back down, and over there is where I will read off Q1. And then I've got to say 75% of my data. In other words, halfway between 25 and 50, so halfway between 25 and 50 is 37,5. And again, it's not always going to be perfectly accurate, but as long as you're able to show what you were doing, that shouldn't be a problem. And there's my Q3. So I can definitely say that Q1 is in the class interval 30 to 40, Q2 is in the class interval 40 to 50, and Q3 is from 50 to 60. So the important thing is, once you've drawn your ogive, have a look on the cumulative frequency axis. So if we spoke to 120 motorists, then you will be reading off your Q2 at 60, because that's halfway between 0 and 120. Right. Malungi, how are we doing there? Before we go to the break, we're getting to variance and standard deviation after the break, so don't stress.
We have a quick question here.
Yes.
Tolofelo. Let me just get the name right. Tolofelo Gomani is asking. Let me just get the question.
Tolofelo.
Yes. Oh my gosh. Okay, there. Liesl, every time I get to the data handling section of paper 2, I seem to have a problem with understanding or interpreting how to determine how many values of the data fall within one standard deviation of the mean. Please help me to understand that.
All right, I will talk about that. In fact, we've got about 50 seconds, so we're getting to variance and standard deviation. So I'm going to call it T, because I'm going to embarrass myself. I'm going to embarrass myself with trying to pronounce the name. So what you will do to figure out how many pieces of data fall within one standard deviation of the mean.
Yes.
So what you will do is you'll have your data, right? And the first thing that you will calculate is your mean. How do we calculate the mean? We take all the data values, we add them together, and we divide by how many pieces of data. I'm making something up. I'm saying that the mean is 11, okay? So point number 1, calculate the mean. Point number 2, calculate the standard deviation, right? So you'll possibly use your calculator, calculate the standard deviation. I'm pretending that my standard deviation is 3, okay? So if they are asking us how many data pieces are within one standard deviation of the mean, you need to say, right, the mean is 11. One standard deviation up from the mean is 11 plus 3, so that's 14. One standard deviation down from the mean is 11 minus 3, which is 8. And Tsolofelo, what you then need to do is calculate count how many of your data values fall between 8 and 14. All right, so you've got your set of data. You calculate the mean, point number 1. Point number 2, you calculate the standard deviation. Then you say the mean plus 1 standard deviation. So that was 11 plus 3. Then the mean minus 1 standard deviation. And now you will go through your data and you will see. If you see 7, no, that doesn't fall between 8 and 14, so that doesn't count. If you see 9, yes, that does fall between 8 and 14, so circle that one and then count how many data values lie within 1 standard deviation of the mean. You can also calculate the percentage. So you can calculate how many you counted in that interval and divide by how many data values there are. Interesting, if your data is normally distributed, then 68% of your data should lie between 1 standard deviation of the mean. I think we're way overdue for a break.
Yes. So, I hope you got that. I hope you were watching. So now, guys, we are going to take a very short break, but do stay tuned. We have more of this data handling coming up straight after the break. Welcome back, Mindsetters. I hope you guys are ready to start again. So I won't waste any more time. I'll take it straight back to Liesl.
Right, guys. We've had so many interesting questions tonight. I wish we had 2 hours, but we don't. So moving on then to variance and standard deviation. Now, as I said before, standard deviation has got the sign, a little sign that looks like that. That's the standard deviation. And the only difference between variance and standard deviation is if you want to get from standard deviation to variance, so that's that way, then you need to square. If you want to get from variance to standard deviation, then you need to square root. Okay. Now, variance and standard deviation in particular, is a very good way to compare things. Let's use the example, for instance, we've got 2 maths classes. In the one maths class, everybody gets around 60%, right? So for that maths class, if I were to calculate their mean or their average will be around 60. Okay. Now, think about maths class number 2. In maths class number 2, we've got a lot of boffins getting 100%, but we've also got people getting 20%. Now, if you average out 120, you're also going to get a mean or an average of about 60, right? So if you were to just look at the mean, you would say class A and class B are the same. But really, you know that they're not, because in class A, everybody gets around 60, and in class B, people get up to 100, but all the way down to 20. So when mean is no longer a good way to compare, that's where we get into standard deviation. Now, what you'll find is in the maths class where everybody gets 60, the standard deviation will be small. But in the maths class where everybody gets, well, either 100 or 20, the standard deviation will be large. So when you're comparing 2 things to each other, if the one maths class has got a small standard deviation, we can say that they are consistent, that they are reliable, and that people perform more or less the same. In the other maths class, where we've got people getting 100 and people getting 20, the standard deviation will be much larger. And there we can say there's a lot more variation. The class is a lot more inconsistent, more erratic, less reliable. So that is the reason why we need standard deviation, is to compare. You can have 2 schools, both with a maths average of 60%, but the one school has a standard deviation that's very, very small. It means that everybody gets close to 60. But the other school, even though they've got the same average, a big standard deviation, that means it's very erratic. You wouldn't want to pick a random student from there, because you could get a genius or you could get somebody who doesn't know what's going on. Right. So that's why variance and standard deviation is useful. And you guys will see in our last question, and we probably won't have time to get to it, and that's why I'm talking to it now, we've got 2 groups of students. Group A, and I've recorded how far these guys can throw a tennis ball. And then group B, I've recorded how far they can throw a tennis ball. And what you're going to do in this question is you're going to use your calculator to calculate the standard deviation for A and for B. Now, just by looking at it quickly, I can see that in group A, everybody could throw the tennis ball kind of around 180. And in this group, there was a lot more variance or variety. So what you'll find when you calculate the standard deviation, maybe we'll get to it, that this standard deviation will be comparatively smaller to that one. All right. Now, there was a question earlier on, people wanted me to calculate variance and standard deviation rather, using both the calculator and the manual method. So I'm going to do that now. And I'm going to do that on a very small data set. So I've got a data set that goes 2, 4, 7, 8, 8, 9. Right. So I want to calculate the standard deviation for these 5 pieces of data. Now, if I use my calculator, I'll bring up my calculator, I'll go to mode, and then I'll go to stat, and then I'll move the calculator out of the way, and then I will pick option number 1 that says VAR. So it's mode, stat, option 1. And then what's going to happen is my calculator is going to give me the opportunity to enter my data. So I'm going to go 2 equals. Don't worry about the frequency column. This is single data value, so the frequency will just be 1. Then I'm going to go 4 equals. Then I'm going to go, then I made my calculator disappear, Looney. Let's go 4 equals, 7 equals, 8 equals, and if a data value appears more than once, you've got to enter it more than once. So I'm going to go 8 equals again, and then 9 equals. All right, so it's mode stat option 1. Enter the data by putting in an equals after every one. Then you go AC shift 1. AC shift 1. And you are going to pick option 4, VAR, that reminds us of variance. And then you're going to pick option 3. Looney, we might have to put this on the website just now.
Oh, okay, cool.
And an equals. And basically what this has done now, it's calculated the standard deviation for us, and the standard deviation is 2,5. 2,49, 2,5. So that's how we do it on the calculator. I'm going to run through the sequence again just very quickly. Maybe guys write it down. Mode. Select stat. Select 1 where you see the VAR. Enter your data by putting in an equals sign after every one. Remember, if a data value appears more than once, you've got to enter it more than once. Then we go AC shift 1, and we pick 4. Now on this screen, there's N. N will tell us how many data values there are. There's 1, 2, 3, 4, 5, 6. So if you were to select N, it will give you 6. If you were to select 2, that's got X with a bar on top, that'll give you the mean of your data. And if you select 3, that gives us the standard deviation, and that's 2,49. We're going to round it off to 2,5. Okay. Now, most of the time, it is perfectly okay to use your calculator. However, if they don't want you to use your calculator, they will give you a bit of a table to fill in. Now, basically, if we look back at the formula, the standard deviation is the square root of the sum of every individual data value, of the mean subtracted from every individual data value, squared and divided by n. Now, I'm going to simplify that by just making a table. The first thing I'm going to do, okay, so I'm going to do like here, and I'm going to put my x values here. These are my data values, 2, 4, 7, 8, 8, and 9. Then I'm going to make another column for x minus the mean squared. All right, now, the first thing we'll have to do is quickly calculate the mean of this data. I'm not using the stats function now, so let's just do it like this. I'm going to say 2 plus 4 plus 7 plus 8 plus 8 plus 9 and divide by 6. I get that my mean is 6,3. Let's call it 6,3. So this is now what you're going to do. You're going to take your individual data value, which is 2. You're going to subtract 6,3 from it. Then you're going to take that answer and you square it. Then you're going to take your next data value, 4. You're going to subtract 6,3 from it. You're going to square it. 7 and subtract 6,3 and square it. and 8 and subtract 6,3 and square it and do that again. 8 minus 6,3 squared, and then 9 minus 6,3 squared. And maybe what you'll do is you'll write down all your answers over here. Now, if you guys look at the formula says add together the individual data value minus the mean squared. So what you're then going to do, in this column, I've got the individual data value minus the mean. So you would have written down every answer here. We're running out of time, so I'm not doing that. In the next column, what you're going to do is you're going to sum these. So you're going to take your answers from 2 minus 6,3 squared. You're going to add all of these answers together. And then you will take the square root of these values divided by n. And remember, n is 6. Now, guys, in this case, because I have been rounding off, when I do it this way, I might not get exactly 2,49, but it should be relatively close. So don't stress about the manual calculation of standard deviation. We will give you a x, another column that says x minus the mean. Maybe we will ask you then to add them together. And then if you guys look at the formula, it's actually quite self-explanatory. All of these individual values added together, divided by how many data values there are. So what I can ask you guys is to practice this yourself. Go to minus 6,3, square it, add it to 4 minus 6,3, and then take the square root of those additions divided by 6, and that should give you the standard deviation. I don't think, Looney, we're going to quite get to the last question, but just while we've still got a minute, anything that I can help our students with?
No, they're still fine here.
Are they fine?
Yes.
All right. Now, guys, just a quick tip if you're going onto the website. If you're doing this last question, very good exercise. Use your calculator. I've shown the calculator sequence to you. Calculate the standard deviation of group A and group B. And remember, when you're comparing standard deviations, the one that's smaller is reliable, consistent. The one that's bigger is erratic, inconsistent. Remember the 2 math classes that I talked about. Everybody gets 60, and the hundreds and the 20s. Guys, I wish I had another hour. I don't. So, Looney, over to you.
Okay, guys, thank you so much for joining us. Remember, 7:15 tonight, we have Connections Live. Check your stuff there, your auto-tune it. Don't change the channel. I suggest that you don't change the channel. Don't even auto-tune it. Don't change the channel. For 15 minutes, guys, just do some push-ups, you know, some stretches if you're tired from the lesson. But make sure you stay tuned for Connections. It plays at 7:15 tonight, and the topic is self-started. So if you want to know how to start your own business, how the guests started their own businesses, if you're interested in all that stuff, make sure you stay tuned. And from us, guys, until next time, thank you so much for tuning in, and we'll see you again. Good night.
Summary. So for the 5-number summary, you need to have the minimum data value. You also need the maximum data value. The next value that you need is quartile 2, also known as the median. Remember, the median is the middlemost value if you've divided your data into 2 equal pieces. Then we also need quartile 1 and quartile 3. Now we'll speak about Q1 and Q3 a little bit later, but basically Q1 is if I take the lower half of the data and I divide it in half again, that gives me Q1, and Q3 is if I take the upper half of the data and I divide it in half again, that gives me Q3. Right, so let's have a look at a practical example. So we're given a very straightforward
Welcome, mindsetters, grade 12s. It is your time to shine with Looney and Liesel. How are you,
Hello
Liesel?
there, guys. I'm very well, thanks, and you?
I'm good, thank you. So what are we doing for the grade 12s today?
Well, we're having a look today at data handling. So that's really a topic that the grade 12s did in grade 11 already. But there's no revision usually in grade 12. So we're giving the guys a chance to go over, and very useful for the grade 11s to watch as well. If they've done it already, again, nice revision. If they haven't, then they'll have a heads up on what's to come.
Okay, cool. I'll send you quickly to your board. Grade 12s, you heard it. Data handling, it's all about the data handling. Yes. Guys, I do know what I'm talking about, but it's just, yeah. Remember, grade 11s, you can also watch, but now it's time for the grade 12s. Remember, you guys can keep in touch with us on Facebook. Our page is facebook.com/learnextra. On Twitter, our handle is @learnextra. Remember, you can download the show notes, the videos, the schedules. If you want to see other products that we also offer, you can go on to learnextra.co.za/live. So with all that said, thank you so much for tuning in. Liesel, I'll take it straight back to you.
Right, guys, welcome to tonight's show on data handling. So let's have a quick look at what's in store for us today. We're going to start off by having a look at our measures of central tendency. Now, our measures of central tendency are our 3 M's. That is the mean, the median, and the mode. Now, grade 11 isn't even the first time that you learned about mean, median, and mode. You should have done these in the junior years already, so this shouldn't be too much of a stretch. So let's have a look quickly, firstly, at the mean. Now, another word that we can use for a mean is the average. So when we're calculating the mean, what we're basically doing is we are adding all of our values together. That's why we use the sigma sign. And we are dividing by how many pieces of data we have. And remember, the X with a bar on top is the sign that we typically use for the mean. Right, so that's the mean, the average. The next one that we're going to have a look at is the median. Now, the median is the value that is exactly in the middle. So if you take your data and you arrange it from smallest to biggest or biggest to smallest, the middlemost value is the median, and we also use the sign Q2 to indicate the median. So the median divides our data into 2 equal parts. Right. Then next up is the mode. Now, the mode is the value that occurs most frequently. Now, mode in Afrikaans, we use the word, instead of fashion, we say mode. Now, you can think of the mode as the fashion. What is the fashion? The fashion is what everybody's doing. So the mode is the data value that occurs most often or most frequently, and we don't really have a special sign to indicate the mode. Right. So we know now what the mean, the median, and the mode stand for. We're also going to have a look today at something called the 5-number summary. Now, the 5-number summary are those 5 important data values that you need in order to draw a box and whisker diagram or a box and whisker plot. So let's move on to the next page. We've spoken about the mean, the median, and the mode. Now we're going to go on to the 5-number.